Okay, in this video I'm going to be talking about some background information, things you're going to need to know before you start solving trigonometric equations. First things first, if this was an equation that I was asked to solve, 3x plus 2 equals 0, you would say I need to get the x by itself. So you would say that 3x is equal to negative 2, x must be negative 2/3. Well, guess what? Over here, if I give you an equation that says 3 sine of x plus 2 is equal to 0, you would end up with the sine of x is equal to negative 2/3. You would work it the exact same way, except in the end we would not get x, we would get sine of x. And this gets us started on the problem. See, from here, we're going to have to do all students take classes. I'm going to have to say, well, okay, and by the way, when you're working these problems, once you get to this point, you have sine of x is equal to something, or cosine x equals something. It's all the same. Every single one of the 30 homework problems you have is exactly the same, in that we need to do all students take classes next. According to this, all students take classes. Sine is going to return a negative value in two quadrants. That would be the third quadrant and the fourth quadrant. And I know that the opposite would be 2 for this angle that we have involved. And I know that the hypotenuse is going to be 3. And I would go from there in solving the problem. Okay, now that doesn't give us a nice neat angle. Maybe that was a bad example in that respect. But that's how you would solve the problem. Then I would find the angle. X would be, and there would be two solutions. Right? This angle over here and this angle over here. Let's say we had something more complicated than 3x plus 2 equals 0. What if I had x squared plus x minus 6 equals 0? Or you would say I need to factor that if possible, and if not, I need to do quadratic formula. Negative b plus or minus the square root of b squared, blah, 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 right? Okay, so if it's not quadratic formula, if we can factor it, that's definitely the easier way. This turns out to be x plus 3, x minus 2 is equal to 0. And then I would set each chunk equal to 0. I would say, well, okay, x plus 3 can be 0 then, or x minus 2 can be 0. And that gives me two solutions. Either x is negative 3 or x is positive 2. Well, guess what? If we're going to do this problem, how did I get 3? If I'm going to do this problem, see the similarities here? X squared plus x minus 6, sine squared x plus sine x minus 6, well, guess what? That factors as well. And this time when it factors, instead of x plus 3x minus 2, it's sine x plus 3, sine x minus 2. That equals 0. And so my two solutions, just like you would work here, instead of x equals negative 3, you would end up with sine of x equals negative 3. Or the second solution, x equals 2, is now sine x is equal to 2. From here, of course, this ends up being no solutions for anybody that's done these problems long enough. Sine, the biggest it can be is positive 1, or negative 1 in the negative direction. But the first thing I would do is, from this solution, I would say I need a sine that gives me a negative value. That tells me that I have two triangles, third and fourth quadrants, right? All students take in classes. And then over here, I have two sine values that return positive values, so I'd have two more solutions. These two would happen to be in the first and second quadrants, and I'd have different triangles, right? So that would be my next step. One more thing to think about. If you ever given something like x plus y equals 1, and I asked you to solve for x and y, you would tell me you couldn't do it. You can't do anything more than that. In order to solve for two different values, I have to have a second equation, right? I would need to know some other relationship between x and y in order to be able to substitute in, or maybe use elimination if I wanted to solve. And the same thing happens with trigonometric equations. All three examples you see here. Sine of x plus sine of y, well, those are two different values. I can't do anything else unless I know some kind of a relationship between the angle x and the angle y. Can't do anything else with this. Cosine x plus tangent x equals 10. I won't be able to do anything with this because these are different functions, different values. Unless I know some relationship between the cosine and the tangent, I can't do anything here. Or maybe I get something like cosecant squared plus secant x is equal to 0. Two different functions. Unless I know a second relationship, I can't do anything with it. And that's where things like our Pythagorean identities come in handy. Because if I see a cosecant squared, maybe I want to go turn it into something else. Maybe I want to relate it to cotangent squared. Maybe I want to put everything in terms of sines and cosines and try to combine fractions or something like that. And so there are all kinds of different routes to do these kind of a problem if you don't have the same answer, but the idea is this: no matter what, the first thing that I want to do on any of these problems, on like the problems like this, is get everything to be the same type of function. Everything here in cosines or tangents. Everything down here in cosecants or secants. And once I get to that point, I can start working.